Hello, you're welcome back. Okay, so now we are looking at a projectile, right? So now, what's a projectile? Now, a projectile is an object whose motion under gravity is parabolic in nature. Okay, so every projectile actually exhibits motion under gravity, but such motion is parabolic in nature. Now, um, this is how the motion of a projectile, okay, is neither vertical, okay, or no horizontal, as we actually considered when we treated linear motion or the motion under free fall, okay, but rather a projectile, though the motion is under gravity, but it moves in a parabolic path from the point of projection to the point it actually returns back to the ground. All right. For example, you have, okay, javelin, the motion of a javelin in air, right? So such motion is called projectile. Now, one thing about a projectile is that the initial velocity, that particular object, okay, is thrown in such a way that the initial velocity u, all right, is at an angle. So if you are throwing a projectile, okay, you have to release it at an angle. So the initial velocity of a projectile is actually inclined at an angle. So now that actually brings us to what is known as a component of a vector. Now, anytime you have a vector quantity, which of course we know very well that a velocity is a vector quantity, right? Okay, and that vector quantity is neither in the vertical direction nor in the horizontal direction, but could only be, okay, be expressed in an angle. Okay, you cannot express in an angle. Such vector, all right, has two components because um, where it is in between, it's neither vertical nor horizontal, so it is said to have two components. What are the two components? All right, it can be expressed in the vertical direction, or it can be considered in the vertical direction, which of course is vertical component, right? When I look at this u, the velocity in the vertical direction, if I consider its value in the vertical direction, that is the vertical component of u. Now if I consider the value of u in the horizontal direction, that will be the horizontal component of u. Okay, so now the question, how do I get this vertical and horizontal component? Of course, simply all I just need to do is for this u, I could actually draw a vertical line to meet any of the reference houses. All right, okay, all right, so which actually the vertical, which of course is the vertical line, all right, which of course is still parallel with this, I'll call it ui. This ui represents the vertical component, then the horizontal, I call it ux. And from what you see here, you can now agree with me that I have ended up creating a right angle triangle whose opposite is actually the vertical component of the initial velocity u, then the adjacent is the horizontal component. So now, having known that, now then let's see how we can get this component. All right, I'm gonna start with the vertical component. All right, so the vertical component is the opposite of this right angle triangle, and of course the velocity itself is the hypotenuse. So that the ratio, the trigonometrical ratio that goes with that is sine theta. Sine theta, of course, you know, is always given as opposite all over hypotenuse. So if I should cross multiply, right? So I will simply have that the vertical component of u, which of course is uy, okay, if I cross multiply, is u sine theta. Excuse me. It's u sine theta. All right. So now that is the, so anytime I consider this the initial velocity in the vertical direction, because some cases I will have to consider in the vertical direction, all right, it will not be to be u sine theta. Now if I should consider it in the horizontal direction, that being the horizontal component, then at that point I'm now looking at the adjacent of this triangle, right angle triangle, and of course with the hypotenuse, which is cos theta. All right, so cos theta is the adjacent, which is ux. Then the hypotenuse is u. So the horizontal component is giving us u cos theta. All right, so now that is it for the vertical and of course horizontal component. So now there are equations, okay, that we need in as much as projectile is concerned, okay, and this equation will help us evaluate some certain parameters, okay, in a projectile motion. And of course these three parameters that we need to evaluate using equations include the time of flight. So in a projectile, one of the things that we need to evaluate is the time of flight of a projectile. Now, how do I actually define the time of flight of a projectile? Now, the time of flight of a projectile is simply the time, okay, it takes for the projectile to actually, okay, complete the time it takes for the projectile to complete its motion. Now, that time it takes for the projectile to complete its motion is divided into two halves. First of all, okay, it is divided into two halves, of course. It is the time it takes for that projectile to reach its maximum height. That is the time it takes for the projectile to move from here to the maximum height. Of course, this is the maximum height. All right, this is the maximum height. Then, of course, this is, I'll call this T1. Then plus the time it takes the projectile to move from the maximum height back to the ground level, which is T2. So that means the total time of flight, okay, is going to be equal to T1, all right, plus T2. Now, seeing both of them are equal, okay, so T1 plus T2, they are equal, so I can just use T to represent it. So that's going to be 2T. So how do I actually derive a formula for this? Now, let's actually look at what we have here. First of all, I will use equation of motion, okay? Now, a projectile is a motion under gravity. So the same equation of motion under gravity is what I'm going to use here. Now, the very first thing I'm going to get is to get the time it takes the projectile to reach maximum height. Okay, and once I multiply by 2, that gives me the time of flight. So now how does that actually happen? Then I will have to write my parameters, all right? Now, first of all, I will now have to write the initial velocity. Remember, the initial velocity I will consider is actually, because I'm looking at the time to reach the maximum height, So I'm considering the vertical component of the velocity. All right. So the vertical component of the velocity, okay, don't forget this u sine theta. All right. Okay, so don't forget that we will still need g in this formula because the motion is under gravity, and of course g is all right. And here we have g is going to be negative, right? Okay, what again do we at maximum height? Don't forget at maximum height, since we are considering now upward movement, right? At maximum height, final velocity is equal to 0, and so we are looking for the time to reach the maximum height. Okay, so now considering this 1, 2, 3, 4 parameters, which equation of motion goes? So the equation of motion under gravity that goes for these 4 parameters is the very first equation of motion under gravity, and you should know that I believe you should remember, okay, that equation is v is equal to u, right, then minus gt. All right, so now v is 0, u of course is the vertical component, which is u sine theta, then minus gt. So rearranging the equation, I'm going to have gt is equal to u sine theta. So now t now becomes going to be u sine theta, then all over g. So that's the time, okay? This small delta t is actually the time that it takes that projectile to reach the maximum height. So please take note of that. U sine theta divided by g. Now, if you are looking for now the time of flight, which is capital letter T, is 2 times the time to reach the maximum height. Already I've told you that, okay? The motion is being divided into 2 halves. All right, so that's going to be 2 times the time of flight, which is 2u sine theta, all over g. All right, so do well to take note of this formula, all right? So what I just did was to give you the proof of this particular formula. But what is really very important is this formula. Okay, so this is the first parameter, right, which of course is time of flight, and that forms our very first equation of projectile. Now we could actually get a second equation, all right, and this time around we need to evaluate what is known as the maximum height of the projectile, the maximum height attained by the projectile. And of course, you know very well that, okay, the maximum height attained by the projectile is simply the vertical distance, okay? The vertical distance actually measured from the ground level. So, of course, so if I want to measure the maximum height, okay, it's always from the ground level, and it's gonna be the vertical distance from the ground level to the point where the projectile reaches its maximum height. So that's h. All right. So this is the maximum height of this projectile. So now, how do I actually prove the formula? How do I get the value or the formula for the maximum height? Of course, my parameters still remain u. All right, the u is u sine theta. All right, the g is still a parameter I need to include, which is negative. All right, then what else do I need? Don't forget at maximum height, very important, v is 0, and Uh, Here we go. Then the maximum height question mark. So considering all these parameters now, which equation goes? That's the third equation. V square is equal to U square, right? Minus 2GH. All right, so of course this is 0, right? Then now it's going to be U sine theta. U is the vertical component, which is U sine theta, okay? All squared, then minus 2GH. So if I should rearrange my equation now, I will have that 2GH, right? Is equal to, open this bracket, U square. If I square U, I'm going to have U square. And if I square sine theta, I'm going to have sine square theta. All right, so that this now gives me H to be equal to U square sine square theta, then divided by 2G. All right, so that is the formula for the maximum height attained by the projectile. Please take note of that formula. It's really very important. All right. Okay, then the last but not the least equation, okay, that we need to evaluate is the range of a projectile. Okay, so this time around, the range of a projectile is simply the horizontal distance, okay, attend the horizontal distance covered by the projectile, okay, which of course is measured from the point where the projectile is being projected to the point where it returns back to the ground. So that means the distance from here to this point, okay, so that is the horizontal distance. So we measure the range horizontally. So in this case now, the U will now be horizontal component of U, which of course is U cos theta, because I'm considering U now in the horizontal direction. All right, then now G this time around is 0. Why? Because in the horizontal direction, right, in linear direction, gravity is not a factor, all right? And of course, the T I need, okay, is going to be the capital T, because at the point where I measure the range, the time that particular object has completed its motion, so the time is going to be the total time of flight, which of course is the capital T. All right, then of course, the range now, which serves as my distance, okay, as my horizontal distance is question mark. So considering all this, which equation of motion goes? Yeah, that should be the second equation, okay, the second equation where R now replaces the H. So that's gonna be R is equal to UT, U, which of course is U cos theta, multiplied by T, which is capital letter T, then of course minus half G is already 0, then T squared. So the whole of this is 0, okay, so I'm only left with thus U cos theta, then multiply by the time of flight. Remember the time of flight of a projectile, all right, which of course is 2 sine theta, which is 2 sine theta all over G. So now with what we have, we're gonna be So this is gonna be u, please pardon me, 2u sine theta all over g. Okay, 2u sine theta all over g. So now u multiplied by u, that gives me u square. Then of course 2 sine theta cos theta, if I have 2 sine theta cos theta. Alright, so then divided by g. So now the range now becomes 2 sine theta cos theta. Alright, is actually in trigonometry we call it compound angle, right? In trigonometry 2 sine theta cos theta is equal to sine 2 theta. Okay, so possibly you should go check out trigonometry compound angle, then you see the proof to this. So now my range now becomes u square sine 2 theta. Alright, then all over g. Okay, so that is it. So now in summary, these are the two equations. Number one, the time of light. Okay, let's so these are the four equations. Okay, four equations. Number one is the time to reach the maximum height, which is just simply u sine theta. Number two is the time of light, which is 2 times u sine theta all over g. Number three, the maximum height attained, which of course is given as u square sine square theta. Sine square theta then divided by 2g. Then finally, the range of the projectile, which is u, which is u square sine 2 theta divided by g. So these four important equations are very key, okay, to solving any question on projectile. So I hope you would definitely take note of them as we look at questions, okay. All right, so we move. Here we have a question. It goes this way. A projectile is fired from the ground level with a velocity of 30 meters per second at an angle of 30 degrees to the horizontal. Calculate the time taken to reach the maximum height. Okay, this should be very simple. Okay, so here we go. The time to reach the maximum height is u sine theta all over g. So this is gonna be equal to, the u is 300, then sine theta then divided by 10. Alright, so this is gonna be 300. Sine theta is 0.5, then divided by 10. So this is gonna be equal to this 150. 300 times 0.5 is 150, and 150 divided by 10, that's going to be 15. Okay, 15 seconds is the answer to that. So that is the part of the question. Then Guys, the option is D. All right, the correct option is D. All right, so now I'll have another example. If a projector has a maximum range of 36 meters, find the speed of the projector. Okay, so now that actually brings us to, when does a projector have the maximum range? At what angle will a projector have the maximum range? Okay, now a projectile will have the maximum range. The range of a projectile is maximum only if the angle of, all right, projection is 45 degrees. What is the reason to this? Why? Because okay, the maximum angle that you will ever get, okay, for sine theta, the maximum angle of sine theta is, okay, is gotten when theta, the maximum angle of sine theta, all right, is gotten when theta is 90 degrees. So it's only sine 90 that will give you maximum angle. So for the range of a projectile, which already we know very well that is given as u square sine 2 theta, okay, all over g. So this actually shows that for me to actually have sine 90, all right, then definitely theta need to be 45, because if I multiply 45 by 2, that will give me 90, and that is when you have the maximum, okay, angle for sine theta, and that gives you the maximum range. So please take note of that. Okay, so now let's look at what we do now. Then we'll have the range, okay, being 36 equal to we are looking for the speed of the projectile, that's u square, that's sine 2 times 2 times theta, right? That's 2 times 45, right? Okay, so please take note of that. Then divided by 10. All right, so of course sine 90 is 1. Sine 90 is 1, all right? So y multiplied by u square is u square. So if I cross multiply, I'm going to have u square to be equal to 360. So now this now gives me u to be equal to the square root of 360. Okay, so you can use calculator to evaluate that. Okay, so here comes another question. A projectile is released with a speed u at an angle theta to the horizontal. With the head of a diagram, show that the time of flight is equal to 2u sine theta all over g, where g is the acceleration of free fall. Okay, so I actually did that proving, so I don't intend to do it again. But the question is, so with the help of a diagram, right? So if I want to use a diagram to show that the time of flight is actually 2u, so it actually simply means that I'm showing the, I want to show the examiner that the total time of flight, okay, is divided into, okay, 2t, that's t1 plus t2, in which each one of them is u sine theta, right? T1 is u sine theta all over g, then plus t2 is also u sine theta all over g. All right, so adding that together, that gives me the time of flight to be 2u sine theta all over g. All right, so That is that. Okay, this one goes like this. The horizontal component of initial speed of a particle projected at 30 degrees to the horizontal is 50 meters per second. If the acceleration of free fall due to gravity is 10 meters per second square, determine its initial speed. So now we are being given the horizontal component. Okay, the horizontal component. Already you know very well that the horizontal component of a projectile, okay, is given as u cos theta. So since the horizontal component is given as 50, right? Then of course you're looking for the initial velocity u. Then the angle the angle is 30, so that's gonna be cos 30, right? So now that way, all right, the u is gonna be equal to 50 divided by cos 30. All right, so here we go. 50 divided by cos 30. All right, so that should be 58 approximately. Okay. Okay, that's a part of the question. Then the speed at the maximum height reached. So at the maximum height, the final velocity at the maximum height is always equal to 0. Okay. Okay. The speed at the maximum height, the final velocity is equal to 0. Okay, so I hope that is well understood. Okay, so that is it for projectile. All right, we are going to look at more in the next video. Right, see you in the next video. Thank you very much.